Coding agents. I mean, these AI entities that can write, debug, and execute code, they're not just a new feature anymore.
Not at all.
They are, I would argue, the most dynamic frontier in applied AI right now.
Absolutely. The rate of development, just the sheer capability gain over the past year alone.
It's staggering. And a lot of experts see this boom in automated software engineering as a key indicator, a signal for how close we might be getting to genuine artificial general intelligence.
To AGI, because software engineering as well is one of the ultimate universal ways to solve problems. It's the perfect testbed.
But that's the trade-off, isn't it? The ground is shifting so fast.
Constantly. I mean, every few months we get a new, significantly more capable model. Think about the GPT 5.1 series or, the latest Codex Max release.
So what's the core problem for developers trying to actually use this stuff?
It's that the core intelligence engines change so often. And because they do, developers are, well, they're trapped in this relentless cycle.
A cycle of just rebuilding.
Exactly. Rebuilding their entire agent architecture just to adapt to the newest model's capabilities, its little habits, its new interfaces.
And that's what this deep dive is all about. We're focusing on how you can break out of that adaptation cycle, how you can find some stability on this very volatile frontier.
That's the mission.
Yeah. We've pulled together some really phenomenal insights from engineers who are wrestling with these problems every single day. We're going to break down the actual components of a coding agent.
The anatomy of it.
Right. And share some specific hard-won lessons from prompt engineering these massive models. Then we'll explore the emerging strategic patterns for using integrated agents like Codex.
So by the end of this, you're not just going to understand what these agents do, but how their internal mechanics really work.
And critically, how you can leverage that knowledge for your own projects. So to start, let's just look at the basic structure. A coding agent, at its core, is surprisingly simple.
It is. It's structured into 3 distinct parts, a simplicity that often gets lost when people talk about advanced AI.
Okay, so what are they?
Well, the first 2 parts are pretty straightforward. You've got the user interface. That's just how you interact with it.
Your command line, an IDE plugin, a cloud platform.
Right, and second, you have the model. That's the core intelligence, the brain. It could be GPT 5.1, Codex Max, you name it.
And the third part, which is the focus of our conversation today, is the harness. This is the piece that really determines if that super intelligent brain is actually useful.
Precisely. The harness is this hugely complex interface layer. It's the critical surface area the model uses to communicate with you, to interact with the codebase, and maybe most importantly, to perform actions using external tools.
Over many turns, right? Not just a single shot.
Over many, many turns. You can think of it as the agent's entire central nervous system. It's really just a collection of specialized prompts and access to tools, all combined within a core agent loop.
So if the harness is the entire control system, does that mean the quality of the harness directly limits the performance of a model, no matter how smart that model is?
Oh, absolutely. The model's intelligence is basically inert without a good harness.
It's just sitting there?
Exactly.
Yeah.
If the harness doesn't frame the problem correctly or manage the conversation efficiently or, correctly interpret what the model is trying to do, that cutting-edge model is essentially hobbled.
Which is why, I guess, for so many successful products that use AI, the harness is what they call the special sauce.
It is the absolute special sauce. It's the key differentiating factor.
Okay, so we know it's important.
Mm-hmm.
But if it's just an interface layer, why is it so hard to build? Why is it so non-trivial?
The difficulty comes from all the moving targets. Take tool integration, for instance.
Right.
You might build an innovative custom tool that handles some unique process for your company, the LLM you're using. It has probably never seen a tool like that in its training data.
So you can't just hand it the tool and say, go.
No, you have to spend so much time tuning prompts.
Yeah.
You're essentially teaching the model how to use your specific tool, and you have to do it all over again every time the foundational model gets an update.
And that's before you even get to the user experience side of things.
Right. Latency is a huge one. When a model is thinking, when it's processing a complex task, how do you show that to the user without, overwhelming them?
Do you stream its internal monologue, or do you just wait and summarize?
Exactly. That decision summarize versus stream, that's purely a harness function, and it drastically impacts how fast and useful the agent feels.
And then there's the big one, context management. That just sounds like an engineering nightmare.
It's the ultimate resource management problem. You have this context window, the history the model can see, and it's limited.
So if your project has, say, 50 files, but the model can only see the last 5 things you talked about.
The harness has to decide what's important. It has to perform compaction.
Which is what exactly?
It's summarizing old history, trimming file contents, figuring out what context is absolutely critical to pass forward without completely overloading that window.
It sounds like the part of agent development that is just never, ever finished.
It rarely is, but we are seeing some relief. What's fascinating is that the newest models, like Codex Max, are actually starting to handle some of this out of the box.
So they're managing compaction and context for you.
Some of it, yeah. It's a huge shift. But even then, the low-level APIs themselves keep changing. The response formats, the schemas. The harness needs constant updates just to make sure you're getting the most out of the model.
So if that's the complexity of the interface, let's pivot to the model's internals. You mentioned this concept of habits being key to prompt engineering.
It's a really powerful distinction. You can look at a model's performance through two lenses. It's raw intelligence.
It's skill in Python or math or whatever.
Exactly. And then it's habits. These are the behaviors it learned during pre-training. Things like always planning before it codes, or gathering context before it makes an edit, or testing its own output. A great harness aligns perfectly with those habits.
And if you don't align, you get what our sources called the overprompting trap. We have a fantastic, really specific example from the launch of GPT-5.
Oh, this one is great. So when GPT-5 came out, it was trained to be exceptionally thorough. It had a very strong habit of verifying context.
Okay.
But initial users, they just tried to reuse their old prompts from older models. And those prompts often had these very explicit instructions like, look really hard at the context and examine every single file before you do anything.
I think I see where this is going.
You can just imagine the collective facepalm across the engineering community. Because GPT-5 was already trained to be thorough, telling it to do that again literally caused this massive slowdown.
It was taking the instructions too literally.
But excruciatingly so.
Yeah.
And the aha moment came when developers stopped trying to guess and just asked the model. They treated it like a collaborator.
They literally asked it, we're trying to speed you up, what should we change?
And the model self-diagnosed the problem. It basically replied, you're telling me to go look at everything, and I don't really need to for this simple task, so that's what's taking forever. It's a perfect example of the advantage you get when you build the model and the harness together, which is the whole strategy behind Codex. The harness is perfectly aligned with the model's habits from day one.
Which brings us to Codex itself. It's really designed as that fully integrated solution, right? An agent for everywhere you code.
Exactly. VS Code plugin, a CLI tool, cloud access. You can even get it on your phone through chat.
And its core functions cover that whole development lifecycle.
The whole thing. It can turn high-level specs into runnable code, navigate huge repositories, execute commands in a sandbox, review PRs on GitHub, even respond to requests in Slack. It's a full-stack partner.
So given everything we just discussed about harness complexity, what is Codex actually managing behind the scenes for the developer?
Oh, the amount of non-trivial work is staggering. It starts with low-level stuff like managing parallel tool calls and then merging those threads back into one cohesive response.
And then there's all the security.
So much security, sandboxing the code execution, secure prompt forwarding, managing user permissions on the fly, port management, the list goes on.
And what about on the optimization side?
Relentless optimization, caching at multiple levels so repeated tasks are instant, plumbing and advanced memory features to handle massive projects. Even things like image resolution compression for multimodal inputs. It's about maintaining a robust, fast, and secure environment 24/7.
I really liked the framing our sources used here. They said Codex isn't just a coding agent, it's a computer use agent for the terminal that totally shifts the scope.
It's a wonderful throwback, isn't it? Before GUIs, how did you operate a computer?
The command line.
You chained commands together. The premise here is that if a task can be expressed with command line input and file interactions, Codex can do it. It breaks down the wall between a coding task and just a general computer task.
So you're not limited to just writing Python or JavaScript.
Not at all. We're talking about delegating things like organizing thousands of your desktop photos into folders, or doing complex data analysis, querying terabytes of CSV files right from the terminal. If the tool exists, Codex can orchestrate it.
It's pure computer task delegation.
Mm-hmm.
Which leads us to the big strategic takeaway from this deep dive. How do you, as a builder, build on top of this?
The major pattern we're seeing emerge is using the Codex harness as the new abstraction layer.
Don't just see it as a tool, see it as a foundation.
See it as a stable foundation. The benefit for you, the builder, is that you no longer have to spend your engineering resources worrying about optimizing prompts every time Codex Max or GPT-6 drops.
You're outsourcing the complexity.
You outsource the entire complexity of that agent model interaction. This frees you up to focus entirely on your product differentiation.
On what makes your app special.
That's where the value is. You leverage the infrastructure, the security, the context management, the tool orchestration, and you dedicate your team to building the unique features that only your application can deliver.
And Codex makes this possible by offering a robust SDK. It works with TypeScript, Python, even GitHub Actions for things like automatically resolving merge conflicts in your CI/CD pipelines.
And this has led to a really incredible evolution in what agents can do. I mean, we started with chatbots, then they got tools like file editors. But the next step is just fascinating.
Okay.
Agents can now be given a tool that allows them to make other tools that they don't have.
An agent that builds its own utility belt on the spot.
It's transformative. Think about enterprise software. Instead of a professional services team writing custom plugin connectors for each customer's API, the agent can now write those connectors programmatically, instantly, just by reading the documentation.
That's incredible.
We even heard about an internal Kanban board built on this system that could identify and fix its own bugs in production.
And we're seeing two distinct strategies in the partner ecosystem for this. You have the Z code editor, for example.
Right. They wrap the full Codex agent inside their environment, so they get all the continuous updates to the agent layer without lifting a finger, and they can focus 100% on building the best editor.
Then you have a team like Cursor, who went for deep customization.
Yeah, they worked really closely with the Codex team to make sure their custom tools were in distribution.
And what does in distribution mean for clarity?
It means their tools and interaction patterns were designed to align perfectly with how the core Codex model, the brain, not the full harness, was originally trained. This lets them build a custom harness on top of the public Codex CLI and get incredible performance.
The numbers really back this up. Codex is seeing huge growth, serving trillions of tokens a week, basically doubling usage since their last big announcement.
And that momentum points us to the future, which is all about the trust ceiling.
Raising the trust ceiling.
It's a safe bet these models will keep getting better, handling much longer horizon tasks without supervision. 6 months ago, you might not trust an agent to deploy a whole web app with database changes.
But
Now, that's becoming a routine, unsupervised task.
So as that trust ceiling rises, what are the next big challenges for an SDK like this?
The challenges shift from just execution to navigation and integration. We're talking about sprawling legacy code bases, working with non-standard internal corporate libraries, making sure the agent can match existing proprietary templates in a closed source environment.
And learning, right?
Absolutely. The future of the SDK has to support learning so it doesn't repeat mistakes. And it has to get much, much better at self-correction when it gets an ambiguous request.
So to pull this all together, harnesses are the defining engineering challenge right now. They take immense effort, constant maintenance. The value of something like Codex is that it gives you a highly capable, off-the-shelf computer agent foundation.
And that frees you, the builder, up.
It lets you concentrate entirely on your product's differentiation, leveraging this incredible core capability without having to become a harness maintenance expert yourself.
Which leads to the really provocative final thought. If an agent can not only write code and execute computer tasks, but can also custom build the tools it needs and then fix its own bugs, how does that fundamentally change the role and the very definition of a human software engineer over the next 5 years?
It is something to think about.
It's something to really consider as you explore what level of complexity you're now able to delegate to this new abstraction layer.